This is Miss Lee again, and we're going to continue with our fraction, decimal, and percent equivalent benchmarks. This is video part 2. We're going to continue with your notes, so make sure you still have them open and that you're filling them out as we go along. Okay, now we're ready to talk about the tenths. Okay, as you'll recall in the first video, we were modeling the common benchmarks, the benchmarks that you should know. And we would model it in our hundreds grid, and this model also can be used for decimals, percents, fractions. Alright, so to model the fraction 1/10, all we're going to do is shade 1 out of every 10. So as I'm looking down, my columns each have 10 squares. So I'm going to shade 1 out of 10, and 1 out of 10. 1 out of 10, and so on, so that when I'm done, this is what my model looks like. And I have shaded 1/10 of the model. So this represents the fraction 1/10. For the decimal, you can see that each row is a tenth because there are 10 of them. So I've shaded one row, which is 1/10. And for the percent, I've shaded 12 of the 100 squares. I'm sorry, not 12, 10 of the 100 squares out of 100, and any number out of 100 can be written as a percent. So 10%. So 1/10 is equivalent to the decimal 1/10 and to 10%. So each time I add a tenth, if I'm going to go to 2/10, then I just add another tenth. And actually, when you say 2/10, it sounds like decimal format already, doesn't it? So 2/10, which is 20, if I double the percent, 20%, 20 out of 100. So 3/10, you can write it just like you say it, and add another 10%, it becomes 30%. And then you have 4/10, which is 40%. You have 5/10, which is 50%. 6/10, which is 60%. 7/10, or 70%. 8/10, or 80%, and then 9/10 for 90%. And of course, if you were to shade the whole model, you would have shaded 100% or one whole. Money. If you want to think about this in money, what 10 coins make up one whole dollar? 10 dimes, right? So you can think dimes whenever you have, and you might want to write this down, whenever 10 is your denominator, you can think of dimes. The numerator tells you how many dimes you have. I have 1 dime. Well, how much money is 1 dime? It's 10 cents. Here I have 3 dimes. 3 dimes is 30 cents. 6 dimes is 60 cents. 7 dimes is 70 cents, and so on. So these are your tenths. Now let's talk about the thirds. Alright, for your thirds, we're going to shade 1 out of every 3. So I'm going to shade 1, leave 2 and 3 blank. Then I'm going to have a new group of 3 and shade 1, leave 2 and 3 blank. 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 Shade 1, and so on. So if I keep doing that, this is what my shaded model ends up looking like. Now, take a look over here. This is a little bit different, so let's take a closer look. And you can see if I start at the last column at the top, I've started a new group, so I shaded 1, left 2 and 3 blank, shaded 1, left 2 and 3 blank, shaded 1, left 2 and 3 blank. And now I'm ready to shade 1, but it has to be out of 3, and there's not a group of 3 here. There is only 1 square left. But I need to shade something. So I need to turn this 1 square into 3. So I can cut it in 2/3, and we'll pretend that those are equal shaped, equal sized, and then I can shade one of them. And that's what you see here. 1/3 is shaded in the last square. So how am I going to write this in decimal format? I know that I have 33 squares shaded, so 33 hundredths, but I have this 1/3 shaded here. What we can do is we can divide. Let me show you what's going to go on. We're dividing 1 divided by 3. And I know I can put a decimal and add a 0. Okay, so 3 doesn't go into 1, but it goes into 10 3 times, which is 9, subtract 1 remainder. And we've learned in 5th grade that we can continue adding zeros and bringing them down and keep dividing to get rid of the remainder. So 3 goes into 10 3 times, which is 9, subtract 1 remainder, bring down another 0. We have a 10 again. 3 goes into 10 3 times. And what do you see happening? The 3 is repeating. Okay? It's never ending. It's not a terminating decimal. It keeps going on and on and on forever. And the way we represent that when we're writing our decimal value is we put this repeat bar over the 3. So this is saying 3300's repeating, meaning this 3 keeps repeating over and over and over again. It never stops. And as the percent, there are 33 whole squares shaded and 1/3 of the last square. So 33 1/3%, or this can also be written as 33.3 repeating percent. Now I don't want you to say, a lot of students make the mistake and they do this. They say, oh, it's 33 repeating 3%. But that's not true, because this is saying that the ones place gets repeated over and over again. And you can't do that, because to the left of the ones place you have the tens, and to the right you have a decimal, and you start with your decimal values. Only the decimal values can be repeated. The ones digit cannot be repeated. So you're not going to write it like that. You have to do 33 decimal, and then you can repeat the 3 that's in the tens place. There's no little trick to remembering 1/3. You're just going to have to memorize it. I think of it 1/3 as being 1/3 repeated, so that 2/3 would be double that amount. 2 times 3 would be 6, so it would be repeating 6s. And you can write that as 66 and 2/3%, or you could write it as 66 and 6/10 repeating percent, either one. So these are your benchmark FDP equivalents. These are the ones that we feel in 6th grade you need to have memorized. Okay? So you need to practice memorizing them, and not just going from fraction to decimal percent, but if I give you the percent, 66.6 repeating percent, you should be able to tell me, oh, that's 2/3, or that's 6600ths repeating. Okay? So let's answer a couple of questions. Let's try to answer these questions without using our notes. If we need to use our notes, that's fine, we can use our notes, but let's try to do it without our notes. We need to identify the fraction, decimal, and percent amount that's shaded in the model. It doesn't matter if you want to look at this as a fraction model, if you want to look at it as a decimal or a percent, it's totally up to you. To me, I can see right away that I have 3 rows. So if I'm thinking decimals, I know that each row represents a 1/10. And since I have 3 of them, that's 3/10. And 3/10, doesn't that sound like a fraction? 3/10, 3 rows shaded out of 10 total rows. And then if we're going to look at this as a percent, we know percents out of 100. I have 30 total squares shaded, so I can write that as 30%. And these are all equivalent. And our last example, in the last inning of the game, Ethan threw 12 strikes out of 18 pitches. Determine if each statement is true or false. All right, so of the pitches Ethan threw, 66 2/3% were strikes. So we need to know the percent that were strikes. We're not given a percent or decimal, but we are given the fact that he threw 12 strikes out of 18 total pitches. We can write this in fraction form. He threw 12 strikes out of a total of 18 pitches. We need to figure out, does this fraction, is it equivalent to 66 2/3%? Well, I know 66 2/3, clue here is 2/3, is 2/3 as a fraction. So let's simplify. I can divide each by 6. 12 divided by 6 is 2. 18 divided by 6 is 3. And they match. So this is a true statement. Ethan's number of strikes to total pitches is 4/9. Okay, so again, 12/18, does it simplify to 4/9? Let me write it next to it. Well, I know I can multiply, if I want to find equivalent fractions, I can multiply 9 by 2 to make 18. But when I multiply 4 times 2, I get 8, not 12. So these are not equivalent. B would be false. Ethan did not pitch strikes 30% of the time. Be careful, because it did not pitch. We know that he pitched 2/3 of the time, and the rest of the time he did not pitch. So what fraction is remaining? 1/3. 1/3 of the time he did not pitch strikes. Is 1/3 equivalent to 30%? No. 1/3 is the repeating threes. So it's 33.3 repeating threes. So it's not 30%. This is false. And Ethan threw a strike for 6/600 repeating of the time. Well, 2/3 we do know is double the 1/3. So instead of repeating threes, it's going to be repeating sixes. So this one is a true statement. Okay, nice job.